capabilities are taking off. When I was starting to really work on the research side at human level and being superhuman at one game at chess, but now superhuman at a lot of things, passing the bar exam, passing medical exams, and then really critically for writing code, the state-of-the-art models like GPT-4 are really good at writing code, and that's actually more important than maybe anything else here because that could help other systems get better really quickly, because that's how you build AI systems, is you write code. So if you're really good at writing code, you can imagine how that might play out. And then can do things like deceive humans pretty easily as well. And what we found is that it's basically this emergent phenomenon where at scale, as you scale up the model, and this is analysis that we are publishing right now, showing this for tax law understanding of these models. But as you can see, as you go from left to right, you hit certain points where the model is big enough, and then you do enough of the right prompting of the model to have it have a generalized ability to reason, that then all of a sudden it's like blowing past the previous models. And how this works is it's really wild, because we're just predicting the next word. So across trillions and trillions of words, we're predicting the next word. So that's a very simple thing, right? But imagine at the limit here. If you can predict the next word every single time, perfectly correctly, we're not there yet, but we're close, across trillions of words, what do you have to do to be able to do that? You have to understand what the person was probably going to say. You have to have reasoning capabilities. You have to have world knowledge. You have to have a model of the world. So these are all instrumental convergent things that have to happen to be able to predict the next word perfectly. So even though that's our objective function, to do that objective function requires a lot of amazing stuff. So that's sort of like how this all even emerges from that simple process. And what we found is there's these capability overhangs. So you train the model, and it's getting lower and lower loss. And that's great, but what does loss even mean? You don't know what that means until you actually prompt it and do all these things, and all of a sudden there's this overhang of all these new capabilities you don't even know about, and they just, you find them, and we're finding them all the time. That's Emergence 1.0, of just predicting the next word, doing that at scale. What we're seeing now is Emergence 2.0, I guess I could call it, where you have the model and or other models interacting with itself. And so as the model is able to produce a lot of synthetic data, it can then go back and revise the data and say this output was better than that output, and just do that by itself. And so now it has even more training data. So it's self-generating training data in a way that is synthetically very useful. And then models are interacting with each other, verifying each other in sort of multi-agent situations. And this is just happening over the past couple of months. And that's unlocking a lot of additional capabilities. And so this is sort of like this in-context learning of prompting it with itself for other models, and then also training itself and actually updating all the parameters with synthetic data. So where does all of this lead? So based on two things, based on the capabilities we just discussed, getting more and more powerful, and then based on just the economic incentives of the world, those two things together lead this towards more autonomous deployments of large language model powered systems. And you can call these agents. So agent in this case is just, I'm going to take more than one action at a time without a human in the loop. That's all I mean by agent. At the limit, you could imagine this thing's going on for years, doing things. We're not there yet. There's kind of a spectrum, but this is the sort of the basin of attraction of where things lead, because economic incentives are such that you want humans out of the loop a little bit, because that's cheaper, and that's just how the world works. And so we're seeing autonomously navigating agents booking your flights. They're doing some tax and legal advice. And then over time, people like Zuckerberg want to introduce a billion agents to everybody. And so as I mentioned, there's sort of a spectrum here, where last year it was fully human in the loop. We're using ChatGPT to write something. We're moving now into this year, where it's things that don't work too well, but they sort of work. We can see where this is going. So for example, ChatGPT can create recipes for you. It actually can go off and then just on its own order the ingredients on Instacart, have them be delivered to your house. That's just a simple example, but you see what I mean in terms of there's no human in the loop for that like two-step situation. And then you can extrapolate that out as the reasoning capabilities get better. There could be many more than two steps in a row without a human in the loop. So I'm talking to a lot of like banks and other groups like that that are trying to deploy these things as agents that are more on the internal side of let's do trade settlement and clearing and stuff all just automated. Right now that's very deterministic rule based, but if you can use an LLM, it can go into new situations and reason around things like a human might. And then maybe within 2 years, we'll have not just like a well-run robo-advisor, but like the superhuman level of like what a human can do for you as a financial advisor, and we can have fully autonomous advisory is one example. So I like to think about this on sort of 2 dimensions here. So on the y-axis, we're looking at the risk of these deployments, of these AI systems in the world. So this is the litigation risk, the regulatory, reputational risk of the companies and people deploying them. And then to extrapolate it further, it's potentially kind of existential risk for humanity. On the x-axis, we're looking at the models getting more and more capable. So starting with like GPT-2, 3, 4, etc. And then one way of thinking about this is that as the models get more capable, it's pretty clear that there's just more things they can do. There's more actions they could take. The space of possibilities is wider. And therefore, we need to further constrain what they can do out of that space of possibilities. If we don't, then it's just going to be unacceptably high risk. We're not going to be able to deploy these things. The companies just are risk averse, as they should be, because they're ultimately liable for this stuff. And then, so we need some sort of guardrails. Like we need some sort of way to constrain the action space, make it economically viable. And we need to be able to do that in a way that's systematic and can specify the goals for the AI. There's a lot of objectives and humans to consider here. We hear people like Sam Altman from OpenAI and others talking about how do we elicit people's opinions, how do we synthesize those, and how do we embed them into ChatGPT or other systems like that. Those are great questions to ask. How do we actually democratically do that? Well, we have one existing solution. It's public law. Like we actually have a way to do that. We don't need to try to reinvent something in Silicon Valley to do some weird aggregation of people's preferences. We have a system of electing representatives and creating law. So this allows us to actually credibly elicit those human societal values, synthesize them into something that we can kind of all get our heads around and implement. And then we have a great process for updating it over time and evolving it with the will of the people. So to visualize this, what these guardrails as law would do, the agent can take any possible action, and then a really small subset of those are actions that are actually aligned with public law. And then even smaller than that are what are the actions aligned with the company or the person that AI agent is working for, essentially. Okay, so how do we do that? What we're working on is actually trying to embed an understanding of law and policy into large language models in a way that they can better understand it, number one, and then number two, in simulation, and then once they're deployed, they can better comply with it, and they can use it as those guardrails to kind of get a smaller action space of the actions that they should actually take. So we're doing a couple things here. One is the large language models, like we talked about earlier, are predicting the next word on text. And that's how they're trained. That's what the pre-training process, that's actually the main way they're imbued with all their knowledge and capabilities. That currently is done on all of the internet, basically. Not literally, but it's mainly, that's what it is. So what we're doing is we're doing two things. One, we're taking that as a starting point, and then we're further doing next word prediction. We're further doing the self-supervised learning, the pre-training on legal text tokens specifically. And then number two, we're from scratch, not even going out to the internet, just training models with that same process on the legal text tokens. So we're starting with a large, probably the largest ever set of that. It's 130 million tokens. The tokens are roughly a word. That's what that is. It's all from legal text. So legislation, regulation, opinions, contracts, etc. And it's basically all English for now. We're focused on the US. And we're working towards getting 1 trillion. And once we get above 1 trillion tokens, then the pre-trained model just on the legal text is going to be able to be competitive with a lot of the models you see out there that are trained on the internet. For example, like Meta released a model called Llama, and that's like really widely used right now, and that was trained on about 1 trillion tokens. So getting up to 1 trillion makes us kind of competitive, And then the interesting thing about legal language is what people have found or hypothesized is that if you train on code, then it embeds some sort of reasoning capabilities into a model, because code itself, programming code, has a lot of structured sequential reasoning baked into the text of the code. And then what people have found is like that's a way to give the reasoning capabilities to the models. And then you have on the other end of the spectrum, you have just natural language you see on the internet. That has a lot of knowledge in it. It has a lot of interesting things, but it doesn't necessarily have the same quality of per token amount of reasoning baked into it. Law is like in between. So it's not fully programming code, but it's also not just typical Reddit text, right? And so it's somewhere in between in terms of the spectrum of how much reasoning is baked into the structure and to the actual words that you're training on. And so that's good, because that's suggestive that as we develop these models further, they'll have strong reasoning capabilities in addition to the ability to understand law. So secondly, we're building these reward models or these fine-tuned models on specific legal standards. So as we all know, like you have rules and you have standards in law. Most law in terms of how it's actually applied is through the process of standards, not just simple if-then rules, because reality is messy and it's hard to, basically our ambiguous goal is to put them into just like if-then statements. So it's mainly in standards, so we're focused on standards, things like fiduciary duties, things like what does it mean to be reasonable, and these are things that over time are sort of iterated on through court opinions. And what we're doing with that is we basically use all those court opinions, turn them into structured data to say, here's a situation in the world, and here's an action that was taken subsequent to that description of that situation, and this was a good action, and that was a bad action, according to the courts. So it's grounded in the legal source of what is good behavior, what is bad behavior, and then we train models on that data, and then now those models have a good understanding of behaviors in the real world that are consistent with particular legal standards, for example, fiduciary duties. So that's the second thing, and the third thing is how do you evaluate all this? Like really cool, like sounding stuff, but how are we sure it's actually working? So there's two main ways of doing that. One is tasks that are used to basically assess humans for their legal understanding. So this is things like the bar exam, a lot of other legal tasks are part of a project at Stanford called Legal Bench, and we're about to release a really comprehensive thing. It's more than 100 things where each of them was lawyers going through and putting together real world tasks that a lawyer would do, and then we assessed a suite of models on all of those tasks. And as you might expect, similar to what I previewed around the tax law thing that I did earlier this year, as you go from GPT-3, 4, et cetera, you're seeing like almost some sort of nonlinear increase in capabilities. In a lot of these tasks, it's at human level. Some of them, it's not. And then the second thing, in addition to these sort of legal understanding, is lawfulness and compliance. So not just do you understand the law, but do you actually obey the law? And so we put the LLMs into simulations, and we tell them that, oh, pretend to be a financial advisor and give advice to this other agent who thinks the other agent's like a human. And so then we kind of antagonistically red team these, and then we run simulations to try to basically get them to misbehave in terms of like what the law would say. And then we see if our techniques are improving that and are leading to less issues and more compliance. So what is the broader picture here? So what does that enable? So by doing that, by getting this law-informed AI, that enables two kind of traditional pillars of the intersection of AI and law. So law can more easily be enforced on AI if the AI understands law. And then AI can inform law, and that's actually what we're about to talk about for most of today, is how can AI actually help with the lawmaking process? How can it find inconsistencies in the law? How can it make it much more efficient to summarize bills, to even write bills potentially? And then what I've just talked about, and we probably won't talk much more about today, but it was more just fun to talk about, are these other things on the right here. This law-informed AI leads to more aligned AI. Aligned in terms of how we define that as a society right now. It leads to more useful AI because you can communicate within legal standards and express our inherently ambiguous goals to AI. And then it leads to more society-aligned AI because there's only one democratic source of societal guidelines, and that's public law. So to close, there's a really cool side effect of all of this work, hopefully the side effect is the vision of empowering lawmaking. So if law is informing and guiding very powerful AI systems, and it's baked into these large language model powered agents, then this makes law even more important. Engaging in the deliberative process for the general citizen is even more exciting now. Hey, I'm going to be doing something that's going to directly inform some super intelligent AI. That's really exciting. And then what we should talk about together today is carefully using AI to help us improve law, to find inconsistencies, to do policy analysis and simulations, and then to maybe even nudge along the process that we currently have, which isn't perfect, but is the best available, of actually eliciting people's opinions and informing them and helping them better come to their own policy conclusions. So